In this video, we will be discussing fault tolerance and highly available architectures. To begin with, let's talk about the meanings behind fault tolerant and highly available. Fault tolerance refers to the ability for a system to remain operational even if some of the components of that system fail. It can be seen as the built-in redundancy of an application's components. Then we have high availability, which is a concept regarding the entire system. Its goal is to ensure that your systems are always functioning and accessible, and that downtime is minimized as much as possible without the need for human intervention. Even if a site is unavailable for a single minute, it can be detrimental to a business. However, Amazon Web Services provides tools to assist in these times of need. The AWS platform is available for users to build fault-tolerant, highly available systems and architectures. AWS is unique due to the fact that users can build these systems with minimal human interaction and upfront financial investment, and it's all customizable to your needs. So let's compare availability for on-premises locations and AWS. Traditionally, ensuring high availability at your local data center can be very expensive and typically only ensured on absolutely mission-critical applications. However, on AWS, you have the options to expand availability and recoverability among whatever servers you choose. You can ensure high availability on multiple servers, multiple availability zones within each region, multiple regions, and also access to fault-tolerant services to use as you please. So let's take a deeper look into how some specific services can assist in providing high availability. We'll look at Elastic Load Balancers, ELB, Elastic IP addresses, Amazon Route 53, auto-scaling, and Amazon CloudWatch. First, we have Elastic Load Balancers, or ELB, which is a service that distributes incoming load or traffic among your instances. ELB can send metrics to Amazon CloudWatch, which is a managed monitoring service. We'll discuss more about that later in the module. So ELB can be a trigger to notify you of high latency or if your servers are becoming overutilized. ELBs can also be customized. For example, you can configure it to recognize unhealthy EC2 instances. It can be public or internal facing. And finally, it can use multiple different protocols. Next, we have Elastic IP addresses. Elastic IP addresses are useful in providing greater fault tolerance for your application. Elastic IPs are static IPs designed for dynamic cloud computing. Elastic IPs are static IP addresses designed for dynamic cloud computing. This tool allows you to mask a failure of an instance or software by allowing your users to use the same IP addresses with replacement resources. Using Elastic IP addresses ensures high availability because your clients can still access your application even if your instances were to fail. Another service is Amazon Route 53. Route 53 is an authoritative DNS service from AWS. This is used to translate domain names into IP addresses. Amazon Route 53 is designed and maintained with the highest level of availability in mind. It was developed to support simple routing, latency-based routing, health checks, DNS failovers, and geolocation routing. All of these characteristics increase the availability of your customer-facing applications. Auto-scaling launches or terminates instances based on specific conditions. This service is designed to assist you in building a flexible system that can adjust and be modified depending on changes in customer demand. With auto-scaling, you can avoid limitations of manually creating new resources. Instead, you create new resources on demand or have scheduled provisioning. This is used to keep your applications and systems running no matter what the load is. It is also important to keep in mind that you can set provisions to scale in or out depending on your policies. Finally, we have Amazon CloudWatch. Amazon CloudWatch is a distributed statistics gathering system. It collects and tracks your metrics of your AWS infrastructure. Another feature is that you have the ability to create and use your own custom metrics. If there are metrics that have passed a set threshold, CloudWatch, in conjunction with auto-scaling, can scale automatically to ensure high availability of your architecture. All right, so let's look at some fault-tolerant tools. First, we have Amazon Simple Queue Service, or Amazon SQS, which can be used as the backbone of your fault-tolerant application. It is a highly reliable distributed messaging system. SQS can help you ensure that your queue is always available. Then we have Amazon Simple Storage Service, or Amazon S3, which provides highly durable and fault-tolerant data storage. Amazon S3 stores all your data redundantly across multiple different devices, across multiple facilities in a region. So if there was ever a failure, you will still have access to all your information. Then we have Amazon Relational Database Service, or Amazon RDS, which is another web service tool for you to set up, operate, and scale relational databases. It provides high availability and fault tolerance by offering several features to enhance the reliability of your critical databases. Some of these features include automated backups, snapshots, and multi-availability zone deployments. All of these different services are highly reliable, highly durable, and fault-tolerant tools for your applications to ensure high availability and fault-tolerant systems. Building a fault-tolerant and highly available architecture doesn't have to be difficult. With the AWS platform, you can utilize the services and tools offered to ensure your applications and systems have high availability and increased fault tolerance. For more detailed information on high availability and fault-tolerant service architectures, visit awsamazon.com/architecture.